Hello viewers, thank you very much for watching GIFT TV. Today's video, we're looking at choosing the correct parametric test. Let's get into it. Parametric tests usually have stricter requirements than non-parametric tests and are able to make stronger inferences from the data that you are using for your analysis. It can also be conducted with data that adheres to common assumptions of statistical tests. The most common types of parametric tests include regression tests, comparison tests, and correlation tests. So let's get into them, each of these parametric test categories. First is the regression test. Regression tests look for cause and effect relationships, and they can be used to estimate the effect of one or more continuous variables on another variable. Regression types. The most common ones are the simple linear regression, the multiple linear regression, logistic regression. And with regards to simple linear regression, you can use this type of parametric tests when you have the predictor variable, which is the same as the independent variable, or the regressor or the experimental variable is continuous, and is only one predictor. But the dependent variable, which is the outcome variable or the criterion variable, is also continuous, but have only one outcome. And a typical example of a research question that goes for simple linear regression, or that allows for simple linear regression to be applied, is what is the effect of income? You know that we have one predictor, which is continuous income, then on longevity, which is also continuous, only one outcome. So you are looking at the effect of income on longevity. And we have one explanatory variable, which is the predictor, which is predicting longevity, and it's income, which is predicting longevity. Then the second one is the multiple linear regression. For this case, we have only two or more predictors, which is also continuous for the x's. Then the y, that is the outcome variable, must also be continuous and only one. A typical example of a research question that supports multiple linear regression is, what is the effect of income? That is one. And the next independent variable is minutes of exercise per day. That is the second x. On longevity, that is the y. The criterion or the outcome variable, the independent variable, which is the y, is the longevity. And the x's, that is the predictor variable or the explanatory variables, are income, minutes of exercise per day. Then for logistic regression, the predictor, that is the s, must be continuous, but the y, which is the dependent variable, must be the binary or might be categorical. So a typical example is, what is the effects of drug dosage on the survival of a test subject? So this is a typical example. What is the effects of drug dosage? So the drug dosage is continuous on the survival of a test subject is categorical or binary. Then we have the comparison test. Comparison test look for differences among groups, means, and they can be used to test the effects of categorical variable on the mean value of some other characteristics. So t-tests are used, underline that t-tests are used when comparing the means of precisely two groups. For example, the average height of men and women. You are comparing men and women with respect to the average height. Then you also have another technique for comparison tests, which is ANOVA and MANOVA. ANOVA and MANOVA tests are used when comparing the means of more than two groups. For example, the average height of children, teenagers, and adults. When you have comparison tests, you have the paired t-test, you also have the independent t-test. You can use the paired t-test when you are dealing with the predictor variable is categorical and it's only one predictor. Then the outcome variable, which is the dependent variable of the y, is quantitative, but the groups come from the same population. Then you can use paired t-tests. An example of a research question that supports paired t-tests is given below. That is, what is the effect of two different test prep programs on the average exam scores for students from the same class. See, that's coming from the same population, students from the same class. Okay, but you're comparing two different test preparation programs on the average exam score. Take note of that. Then you can also apply the independent t-test when the predictor variable is also categorical and you only have one predictor. Then the outcome variable, which is the dependent variable or the criteria variable or the y, is also quantitative, but in this case, the groups come from different populations. The difference between the paired t-test and the independent t-test is that for the paired t-test, it comes from the same population, but for the independent t-test, it comes from different population. And a research question, typical research question that support independent t-test is giving us what is the difference in the average exam scores for students from two different schools? Underline that, two different schools. This is two different schools. Unlike the first one for the paired t-test, which was coming from the same class. Take note of that, different schools. So it's coming from different populations. Then, for the case of ANOVA, the predictor variable, which is the X's, must be categorical, okay? That is, must have one or more predictors. But for the outcome variable, which is the Y or the dependent variable, it must be quantitative, that is numeric, and must have only one outcome. A typical example of a research question that support ANOVA is what is the difference in the average pain levels among post-surgical patients given 3 different painkillers. So you are testing across the 3 different painkillers. All right, so you see that we have more than one predictors. Because you have 3 different predictors, 3 different painkillers. You can use ANOVA. But for the case of MANOVA, the predictor variable, that is the X, must be categorical, no doubt about that. And it must also have one or more predictors, like the same for the ANOVA. But the dependent variable should be more than 2 or 2 or more outcomes, should be more than 1. Unlike the case of ANOVA, where the dependent variable is only 1 outcome, but for MANOVA, the dependent variable should be 2 or more outcomes. And it must be numeric or it must be numeric or quantitative in nature. A typical research question that supports MANOVA test is, what is the effect of flower species? Take note of that. What is the effect of flower species on 1, petal length, 2, petal width, and 3, stems length? So you have 2 or more outcomes. You are trying to find the effect of flower species on petal length, that is 1 outcome, petal width, 2 outcome, and 3, stem length. That's the 3rd outcome. So you see that we have 2 or more dependent variable that you are trying to find. You are using the flower species to find its effect on these 3 outcomes. Then, in this case, you can apply the MANOVA. Correlation test. Correlation test check whether variables are related without hypothesizing or finding any hypothesis for a cause and effect relationship. So you can only apply correlation tests to check whether variables are related without hypothesizing a cause and effect relationship. This can be used to test whether 2 variables you want to use in your multiple regression test are uncorrelated or are autocorrelated or not. So for the case of these correlation tests, you can apply the persons are when we are dealing with 2 continuous variables, and typical research question that support persons are or correlation test is, how are latitude and temperature related? How are latitude and temperature related? In summary, parametric tests are able to make stronger inferences from the data, and above all, they can only be conducted with data that adheres to the common assumption of statistical tests. Thank you very much for subscribing to GIFT TV, and I will see you all in the next video. Thank you.